Alright, let's start with 28. 28 says, according to student 1, which of the following quantities is greater for the water molecules beneath a lake's surface than for water molecules at the surface? And our answer choices are temperature, density, buoyant force, and hydrostatic pressure. Notice that I've highlighted student 1, greater, and beneath a lake's surface, which means that I want to look only at student 1, and I want to know which is going to be greater at water below the surface and the surface. So I have categories here, but I'm looking for here to be larger. And I want that to be a bigger quantity. So, water freezes first at the temperature at the surface of lakes, which means it's probably going to be colder first, and then that temperature will be greater below the surface because that has to get thicker. Under the surface, hydrostatic pressure causes the freezing point to be slightly lower than it is at the surface. So that means the freezing point here is lower. It says it right in that passage. Only as the temperature becomes even colder will the layer of ice at the surface become thicker. Pressure is defined as force divided by the surface area over which the force is exerted. There's going to be a larger area deeper down, and then a larger force, which means that this pressure is actually going to get bigger. Scientist number 1, student 1, doesn't talk about density or buoyant force, and we know that temperature is lower, which means that J is the only option. So for here, you use process of elimination. The most important part of this passage here is it says the freezing point of water is slightly lower than it is at the surface. That tells you that F absolutely cannot be there. All right, let's go 29. When two skaters wearing identical skates skated across a frozen lake at the same speed, the ice under the blades of skater B was found to melt faster than the ice under the blades of skater A. What conclusion would each student have? So let's look at the skaters. Student 1 says, an ice skater exerts the entire force of her body weight over the tiny surface area of two very thin blades. That's a very large pressure, which quickly melts a small amount of ice directly under the blades. Student 2 says, ice melts under an ice skater's skates because of friction. The energy used to overcome the force of friction is converted to heat. So the force of friction and that energy is heat, which melts the ice. The greater the weight of the skater, the greater the force of friction. So let's revisit the question. The ice under the blades of skater B, and notice that they're going at the same speed in identical skates. That's a control. And the ice under skater B melted faster. So both of these people say that it has something to do with the force. So the answer here is B. Both student 1 and student 2 would conclude that skater B is heavier. Skater B is heavier according to student 1 because the larger the pressure, the more quickly the ice melts. And skater B is heavier according to student 2 because the greater the weight of the skater, the greater the force of friction. All right, going on 30. Which student, if either, would predict that ice will melt under the blades of an ice skater who is not moving? The answer here is F. And I know that without even revisiting the passage because student 2 says that it's friction, which means that it has to move. And this one says that it's pressure, which means that it does not. It's simply from the weight. All right, 31. A beaker of ethanol, that's just alcohol or rubbing alcohol, is found to freeze from the bottom upward instead of from the surface downward. So that's unlike ice in a lake. Student 2 would most likely argue that the density of frozen ethanol is. So let's go back to student 2. Water freezes first at the surface of lakes because the density of ice is less than that of liquid water. So water freezes at the top because ice is less than water. But this one freezes at the bottom, which means that the density of frozen ethanol is going to be greater than the density of liquid ethanol, because that's why it would be at the bottom. So that includes what you know about density, so more dense at the bottom. and why it's freezing from bottom upward. So that's the only one that could be. All right, 32. A toy boat was placed on the surface of a small pool of water, and the boat was gradually filled with sand. After a certain amount of sand has been added, the boat began to sink. Based on student 2's explanation, the boat began to sink because. So, student 2, if we go back to this passage, says the buoyant force of water is greater than the force of gravity, and all ice particles float to the top. So the buoyant force of water is greater than gravity, and that's why they float. So for a boat to start sinking, that means that the buoyant force is less than gravity. And that's the only way that could happen. So the answer, if we look at our choices, hydrostatic pressure became greater than the buoyant pressure of the boat. Atmospheric pressure became greater than the buoyant force of the boat. Neither of those talk about gravity, so we can cross off F and G. H says the force of gravity of the boat became greater than the buoyant force of the water, and the force of gravity became less. So we can cross off J because we know that what makes things float. So then our answer for 32 is H. And 33. So, according to student 2, if friction between the ice and the blades of an ice skater's skates is reduced, which of the following quantities simultaneously decreases at the point where the blades and the ice are in contact? So, if friction is reduced, which of the following quantities decreases? So if we look at what friction does, it says the energy used to overcome friction is heat, converted to heat. So, the answer here, if we go back to the passage where it says that heat from the friction is converted to energy, we have that option right here. So the answer to 33 is simply just heat produced. And the final question for this passage. Based on student 2's explanation, the reason a hot air balloon is able to rise above the ground is that the balloon and the air inside it are less dense than the air outside the balloon, more dense than the air outside the balloon, at a higher pressure, or less buoyant. So we know that the floating happens because gravity is less than buoyant force. So it's the opposite of what we have written for question 32. So what do we think would happen here? And if we go back to it, the answer would be F, because if it's less than the buoyant force, that means it's going to be less dense here. So the air outside the balloon, that's just your air here, has to be more dense so that our less dense object will float to the top of the air, and that's our hot air balloon. This is a terrible drawing. Ignore that. That's your hot air balloon. So the only way that the air balloon would float is if it was less dense and could travel upwards to the top because it wants to be above the more dense air. So here's your more dense air, and this is less dense. And that's why your air balloon would work.